Okay, students, this is for some examples of your extra credit radicals worksheet. And of course, I have to see work on each of the problems where work can be shown or you don't get credit. I always have to repeat that because some kids think they're going to turn in answers that they get from somebody else and think they're going to get any credit whatsoever. Unfortunately, they still haven't learned in all these years. Okay. Uh, the first part is just simplifying radicals. You've done that. You just did a worksheet on division of radicals and rationalizing the denominator. Also of multiplying radicals. A new piece would be if I have variables in it. Square root of, say, 27 x to the 5th, y to the 12th. Okay, so I break down the square root of 27. First off, you need to remember this means square root. So it's really a 2 there. We just never write the 2 there. So what is the square root of 27? That is 3 root 3. Notice I left space in between here because I have to deal with my variables as well, put what I can outside. The way I teach it very simply is I just take this, let me change the color, take the exponent and divide by the root, whatever the root happens to be. In yours, since this is algebra 1, it's only going to be root 2 every time. So what is 5 divided by 2? 5 divided by 2 is 2 remainder of 1. The 2 is the exponent that goes on the outside. The remainder tells me how many x's I have on the inside. So doing that same thing, I have 12 divided by 2, and that goes in evenly of 6, so it's just y to the 6th, and I have no remainder, so there's no y's inside there. That is how you deal with variables. That's the quickest shortcut you can do. Okay. To go along with that, let's say we have a radical with a variable in the denominator. So let's say I have square root of 24 over x to the 5th. Well, x to the 5th is not a perfect square because I'm dividing by 2, right? That's 2 remainder of 1, isn't it? I can't have any remainders. Okay, so I need to go ahead and multiply by another one more x, right? Because what is 5 plus 1? 6. Doesn't 6 divide by 2 evenly? Yes, it does. And then remember, x over x is really just 1, so I haven't changed the problem. So now I have square root of 24x over x to the 6th. Okay, and I go ahead and break it down. Square root of 24 is 2 root 6. Notice I still have an x in the numerator up there. Can't do anything with. And x to the 6th, so 6 divided by 2 is 3. So now that 3 is on the outside. And so there's my, I'll rewrite this closer. There's my final answer, 2 root 6x over x cubed. Notice no radical in the denominator now. Okay, there's that type. Next one. Let's say I have 4 over 3 minus the square root of 3. Again, I have a radical in the denominator. Cannot have that. So what we multiply by is what's called the conjugate. Multiply by the conjugate. And you will do this in Algebra 2 and pre-calculus. Multiply the conjugate. The conjugate is basically set up as a difference of squares. So remember, what is the difference between the two factors in difference of squares? The only difference is the sign in the middle. It's the opposite sign. So it's 3 plus root 3. And of course, that's going to be the same thing in the numerator and denominator because that makes it 1 again. So I'm not changing the problem. Now when I multiply through, obviously I'm going to distribute the 4 through here. And so I get 12 plus 4 root 3 all over. Well, I should actually wait to do that in case I can cancel. So I'll leave that first to see if that 4 will cancel with my denominator. Then if it doesn't, some answers will let you leave it like that, others will have you multiply it through. So since it's set up as a difference of squares, remember that wipes out the middle term. So all I have to do is multiply the two first terms together. 3 times 3 is 9. And the negative times the positive is negative. And root 3 times root 3, the last two together, is 3. So then notice I get 4 parentheses 3 plus root 3 over 6. So then 4 cancel the 6, 2 to 3. Okay, now I can go ahead and distribute the 2 through there. So I get 6 plus 2 root 3 over 3. And that's usually how you'd see the answer. Okay, you'll again, like I said, do this in algebra 2, called multiplying by the conjugate or conjugation to get rid of the radical. Okay. It doesn't matter if you have 1 or 2 radicals down there. So let's do one more example of that. With 2 radicals in the denominator. So I have 2 over root 6 plus root 2. It doesn't matter if I had 1 or 2, I'm still doing the exact same thing, multiplying by its conjugate. Remember that conjugate, all I do is switch the sign in the middle. Everything else stays the same. So it becomes negative this time in the middle. And of course, I'm multiplying numerator and denominator by the same thing, so it's equal to 1, so I'm not changing the problem. Okay, and then I have 2 times root 6 minus root 2. We're not multiplying this through yet in case that 2 cancels. And then, of course, root 6 times root 6 is 6. Positive times negative is negative. And root 2 times root 2 is 2. So now I have 2 parentheses root 6 minus root 2 all over 4. Of course, the 2 cancels the 4 2 times. So therefore, this is my final answer. Okay, I expect to see all of this work. So obviously on these ones here, you probably aren't going to have room to do it on the sheet itself. So you need to put it on a separate sheet of paper, unless you write small. Okay, backside deals with adding and subtracting of radicals. Okay, add or subtract radicals. Okay, example. So first off, just so you know, if I'm going to add or subtract a radical, in order to add the radicals together, subtract the radicals together, they must have the same radical. So square root of 2 and a square root of 2. And I just add or subtract their coefficients, the number out front. I don't switch the radical, nothing happens to the radical. It remains the same. So like a common denominator. The denominator remains the same. That's like the radical remains the same. I just add or subtract the numerators and fractions. Okay, when I'm dealing with fractions. So it's the same idea. So if I have unlike radicals, then they have to stay separate in your answer, just so you know. So let's take an example. I'll even do an example right here from whatever. I don't even know if we're on 5 or 6, whatever. It doesn't matter. I'll do one right from your homework. 8 root, right from the extra credit sheet. 8 root 54 minus 4 root 6. Okay, obviously root 6 is broken down all the way. That doesn't simplify anymore. But root 54 does. Now here's an idea, a shortcut that will help if you can't figure out what it is. In order for me, like I just told you, in order for me to subtract these radicals together, the roots must be the same. Well, since that root 6 doesn't break down anymore, then this would have to have a root 6 in it in order for me to combine it. So that tells me divide 6 into 54, and I get 9 perfectly. Okay, so now I can see how I'm going to be able to put these together. And what is root 9? 3. 3 times 8 is 24 root 6 minus 4 root 6. And again, since they're the same radical, I can just deal with their coefficients. 24 minus 4 is 20 root 6. The root 6 part doesn't change, just like the denominator doesn't change when you add or subtract fractions. Okay. So the same rule would apply with addition. It doesn't matter. So the first several on that back page, you have just 2 that you're dealing with. We'll deal one with 3. Okay, let's see. I'll do 14. Root 40 minus root 10 plus root 90. Okay. Now again, if I'm going to be able to add them all together, this root 10 has to be the one that's common because root 10 doesn't break down. So I'm going to divide each of these by 10. And so that'd be 4 times 10. And that would be 9 times 10 to get my 90. Okay? And they all work out perfectly. So then I get 2 root 10 minus 1 root 10 plus 3 root 10. And so I can go 3 plus 2 is 5, minus 1 is 4 root 10. Remember, the root doesn't change, just like the denominator. When I add or subtract fractions, I'm only adding and subtracting my coefficients. Okay? And that should do it with anything that you need to know on either side. Just don't forget when it says root 10, that really means a 1 out front. That's why I wrote it this time. So you remember that. That's a 1. Okay. Other than that, we've already dealt with, like I said, simplifying radicals, multiplying them, dividing them. And I've now just added the extra pieces into there. So that's all you should need to know to be able to, if you need to go back and watch the other video with the radicals, then go ahead and do that. But this is any of the new potential stuff that you haven't seen yet.